Lesson. Graph rational functions. Despite the prevailing use of graphs as metaphors for communicating and reasoning about dependencies, the task of capturing informational dependencies by graphs is not at all trivial. Judea Pearl. Steps to graph rational functions. First, find the domain. Next, find the intercepts, x and y intercepts. Next, write the equations of the asymptotes and holes, vertical, holes, horizontal, and slant. Then, make a table of values and signs for the rational function. Sketch the coordinate system, the intercepts, and the asymptotes. And finally, graph. Question 1. F of x equals 2x plus 1 everything over x minus 3. Domain. The denominator does not equal 0. Thus, x minus 3 does not equal 0. Equivalent to x does not equal 3. The domain is then open negative infinity 3 united with open 3 infinity. Intercepts. X-intercept at y equals 0. A fraction is 0 when the numerator is 0. Thus, 2x plus 1 equals 0, which is equivalent to x equals negative 0.5. The x-intercept is at point of coordinates negative 0.5, 0. Y-intercept. X equals 0. Y equals f of 0, which equals 2 times 0 plus 1, everything over 0 minus 3, which equals negative 1/3. The y-intercept is point of coordinates 0, negative 1/3. Asymptotes. Vertical asymptote. 3 is excluded from the domain of the function. We could have a vertical asymptote or a hole at x equals 3. X minus 3 is a factor of the denominator, but not a factor of the numerator. Thus, x equals 3 is the equation of the vertical asymptote. Indeed, when x approaches 3 from the left, y approaches 2 times 3 plus 1, everything over 3 from the left minus 3, which equals 7 over 0 from the left, which equals negative infinity. When x approaches 3 from the right, y approaches 2 times 3 plus 1, everything over 3 from the right minus 3, which equals 7 over 0 from the right, which equals positive infinity. The equation of the vertical asymptote is thus x equals 3. Hole. The only excluded value from the domain is x equals 3. Therefore, the graph of function f has no holes. Horizontal asymptote. The degree of the numerator is 1. The degree of the denominator is 1. The leading coefficients are, as you see here, 2 and 1. The degree of the numerator is equal to the degree of the denominator. Thus, the equation of the horizontal asymptote is y equals the ratio of the leading coefficients. y equals 2. Indeed, when x approaches plus or minus infinity, y equals x times the quantity 2 plus 1 over x, everything over x times the quantity 1 minus 3 over x, which equals 2 plus 1 over x, everything over 1 minus 3 over x, which approaches 2. The equation of the horizontal asymptote is y equals 2. Make a TVS, table of values and signs. Include in the table all the zeros of the numerator and the denominator. Negative 0.5 and 3. So we've created our TVS as shown. At positive infinity, both the numerator and the denominator are positive. Thus, the fraction is positive. A rational function could only change the sign at a zero of the numerator or denominator. Thus, the function is positive on open 3 infinity. The zero of the denominator, namely 3, has an odd multiplicity. Thus, the rational function changes the sign in the vicinity of 3. So it changes sign from positive to negative. The zero of the numerator, namely negative 0.5, also has an odd multiplicity. Thus, the function changes the sign in the vicinity of negative 0.5. The graph of f is above the x-axis on open negative infinity, negative 0.5, united with open 3 infinity, because f of x is greater than 0 on these intervals. The graph of f is below the x-axis on open negative 0.53, because f of x is less than 0 on this interval. Make a sketch. Draw the coordinate system, place the x-intercept, and place the y-intercept. Draw the vertical asymptote. Draw the horizontal asymptote. The graph could start above the horizontal asymptote or below the horizontal asymptote. Because the graph must go through the point of coordinates negative 0.50, the graph must start below the horizontal asymptote. Between negative 0.5 and 3, the graph is below the x-axis, crossing the y-axis and approaching the vertical asymptote x equals 3 from the left. X approaches 3 from the right, y approaches positive infinity. Thus, the graph starts on the top, on the right side of the vertical asymptote, x equals 3. The graph decreases and approaches the horizontal asymptote, y equals 2. This is the graph of the function f. The range of the function is open negative infinity 2 united with open 2 infinity. Method 2. F is a rational function. Both the numerator and the denominator have a degree of 1. Thus, we can divide using long division, synthetic division, or writing the function differently. The multiples of the denominator are x minus 3, 2 times the quantity x minus 3, etc. If we create a multiple of x minus 3 in the numerator, it would be faster and easier to divide. 2x minus 6 is a multiple of x minus 3. 2x plus 1 is the same as 2x minus 6 plus 7. Thus, f of x is equal to 2x minus 6 plus 7, everything over x minus 3. Apply the distributive property of division over addition, which states that a plus b everything over c is equal to a over c plus b over c, which then results in f of x being equal to 2x minus 6, everything over x minus 3, plus 7 over x minus 3. Factor 2 in the numerator and reduce, obtaining 2 times x minus 3, everything over x minus 3, plus 7 over x minus 3, which equals 2 plus 7 over x minus 3. The parent function is g of x equals 1 over x, with a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. G is decreasing on open negative infinity 0 and decreasing on open 0 infinity. The transformation is f of x equals a times g of b times the quantity x minus h, everything plus k. H equals 3, which means there is a horizontal shift to the right 3 units. The equation of the vertical asymptote of the transformation is x equals 0 plus 3, or x equals 3. K equals 2, which is a vertical shift up 2 units. The equation of the horizontal asymptote of the transformation is y equals 0 plus 2, y equals 2. This is the sketch of the transformation. The path is similar to the parent function. Important: the graph of the function can be used to find the range of the function f. The range is open negative infinity 2 united with open 2 infinity. Because the horizontal asymptote, y equals 2, is never crossed. Thus, y cannot be 2. Question 2. F of x equals 1 over 4 times the quantity x plus 2, everything squared, everything minus 4. The domain. 4 times the quantity x plus 2, everything squared, cannot equal 0, which is equivalent to x does not equal negative 2. The domain is thus open negative infinity negative 2 united with open negative 2 infinity. As for intercepts, x-intercepts occur when y equals 0. This is equivalent to 1 over 4 times the quantity x plus 2 everything squared minus 4 equals 0. This is a rational equation. Separate the variable and write 4 as a fraction. Equivalent to 1 over 4 times the quantity x plus 2 everything squared equals 4 over 1. This is a proportion, so we can cross multiply. Equivalent to 16 times the quantity x plus 2 everything squared equals 1. To separate the variable, divide both sides of this equation by 16. Equivalent to x plus 2 everything squared equals 1 over 16. Square root of 1 over 16 equals 1/4, which equals 0.25. Because of the difference of squares formula, the special quadratic equation has 2 possibilities. X plus 2 equals negative 0.25, and x plus 2 equals 0.25. x1 equals negative 2.25, and x2 equals negative 1.75. Thus, the x-intercepts are points of coordinates negative 2.25, 0, and negative 1.75, 0. As for the y-intercept, that occurs when x equals 0, y equals f of 0, which equals 1 over 4 times the quantity 0 plus 2 everything squared, everything minus 4, which equals 1 over 16 minus 4, which equals negative 3.9375. Thus, the y-intercept is point of coordinates 0, negative 3.9375. Asymptotes. Vertical asymptote. Negative 2 is excluded from the domain. Thus, the function either has a vertical asymptote or a hole at x equals negative 2. When x approaches negative 2, y approaches 1 over 4 times 0 positive minus 4. Regardless of whether we approach negative 2 from the left or the right, we obtain a 0 positive at the denominator because of the square. Y approaches infinity. So the vertical asymptote is x equals negative 2. Holes. There is no other value excluded from the domain. Thus, the graph of f does not have a hole. Horizontal asymptotes. When x approaches plus or minus infinity, y approaches 1 over infinity minus 4. Thus, y approaches negative 4. Y equals negative 4 as our horizontal asymptote. Then our slant asymptote, the graph of f has a horizontal asymptote at negative infinity and positive infinity. Thus, the graph cannot have also a slant asymptote. Table of values and signs. Place the zeros and the excluded values of the function. Our 2 zeros. And our excluded value from the domain is negative 2. At positive infinity, the function is negative because y approaches negative 4. A function does not change the sign unless it goes through a 0 or an undefined value. The function continues to be 0 until negative 1.75. The function changes the sign in the vicinity of negative 1.75 because the 0 has an odd multiplicity. The function does not change the sign in the vicinity of negative 2 because negative 2 has a multiplicity of 2, which is an even number. The exponent is 2, thus the multiplicity is 2. The function changes the sign in the vicinity of negative 2.25 because the 0 has a multiplicity of 1. The graph is below the x-axis on open negative infinity negative 2.25 united with open negative 1.75 infinity. The graph is above the x-axis on open negative 2.25 negative 2 united with open negative 2 negative 1.75. Make a sketch. Place the intercepts first, our 2 red dots, and then our third intercept, which is that purple one right there. Draw the vertical asymptote x equals negative 2. Draw the horizontal asymptote y equals negative 4. Towards negative infinity, the graph is either above the horizontal asymptote y equals negative 4 or below. The graph must cross the x-axis before it rises towards positive infinity on the left side of the vertical asymptote x equals negative 2. Thus, towards negative infinity, the graph must be above the horizontal asymptote. The graph is above the x-axis on open negative 2, negative 1.75. Thus, the graph continues at the top right side of the vertical asymptote x equals negative 2. The graph is below the x-axis on the open interval negative 1.75 infinity. Thus, the graph crosses the x-axis and approaches the horizontal asymptote towards positive infinity. Thus, this is the graph of f. The range of the function f is negative 4, infinity. Method 2. Parent function. G of x equals 1 over x squared. The domain of that is open negative infinity 0 united with open 0 infinity. Vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. The transformation is f of x equals a times g of b times the quantity x minus h, everything plus k. F of x equals 1 over 4, everything over x plus 2, everything squared, minus 4. A is equal to 1/4, which is a vertical compression by a factor of 4. H equals negative 2, which is a horizontal shift to the left 2 units. K equals negative 4, which is a vertical shift down 4 units. X transformation is equal to 1 over b x parent plus h. Thus, the vertical asymptote of the transformation is x equals negative 2. Y transformation equals ay parent plus k. Thus, the horizontal asymptote of the transformation is y equals negative 4. Sketch the transformation. The vertical asymptote x equals negative 2. The horizontal asymptote y equals negative 4. The transformation has no reflections. Thus, its sketch follows the same type of path as the parent function. Above the horizontal asymptote and increasing towards the vertical asymptote. Sketch it just like that in purple. Then, it continues from the top on the right side of the vertical asymptote and decreases towards the horizontal asymptote. This is thus the graph of f. Question 3. F of x equals the quantity x minus 1 everything squared times the quantity x minus 4 everything over the quantity x minus 2 everything squared times the quantity x plus 3. Domain. X minus 2 everything squared times the quantity x plus 3 does not equal 0, which is equivalent to x cannot equal 2 and x cannot equal negative 3. Thus, the domain is open negative infinity negative 3 united with open negative 3 2 united with open 2 infinity. Intercepts. X-intercepts occur when y equals 0. A fraction is 0 when the numerator is 0 and the denominator is not 0, which is equivalent to x equals 1 or x equals 4. Thus, our x-intercepts are points of coordinates 1, 0 and 4, 0. Y-intercept occurs when x equals 0, y equals f of 0, which equals 0 minus 1 everything squared times 0 minus 4 everything over 0 minus 2 everything squared times 0 plus 3, which equals negative 4 over 12, which equals negative 1/3. Thus, the y-intercept is point of coordinates 0, negative 1/3. Asymptotes. Vertical asymptotes. Negative 3 is excluded from the domain of the function. We could have a vertical asymptote or a hole at x equals negative 3. Negative 3 is not a root of the numerator. Thus, x equals negative 3 is the equation of the vertical asymptote. Indeed, when x approaches negative 3 from the left, y approaches, after doing some careful calculation, 16 times negative 7, everything over 25 times 0 from the left, which evaluates to positive infinity. When x approaches negative 3 from the right, y approaches 16 times negative 7, everything over 25 times 0 from the right, which equals negative infinity. Thus, the vertical asymptote is x equals negative 3. 2 is excluded from the domain of the function. We could have a vertical asymptote or a hole at x equals 2. 2 is not a root of the numerator. Thus, x equals 2 is the equation of the vertical asymptote. Indeed, when x approaches 2, y approaches 1 times negative 2, everything over 0 positive times 5, which evaluates to negative infinity. Horizontal asymptotes. The degree of the numerator equals the degree of the denominator, which equals 3. Thus, y equals the ratio of the leading coefficients, which is the ratio of 1 to 1, which equals 1. Y equals 1 is the equation of the horizontal asymptote. Indeed, force factor x from the first parentheses equals x squared times the quantity 1 minus 1 over x, everything squared. Force factor x from the second parentheses times x times the quantity 1 minus 4, everything over x. Multiplication is commutative. The product of x squared and x is x cubed. So we simplify our numerator, following the same procedure in the denominator. Reducing the fraction by x cubed. When x approaches plus or minus infinity, 1 over x approaches 0. Therefore, y approaches 1. The horizontal asymptote is y equals 1. Make a table of values and signs. Place on the number line the zeros of the numerator, 1 and 4. At these values, the fraction is 0. Place on the number line the zeros of the denominator, negative 3 and 2. At these values, the fraction is undefined. At positive infinity, y is approaching 1. Thus, f of x is positive. The sign of a function might change only at the zeros of the numerator or zeros of the denominator. Thus, f is positive on the open interval for infinity. 4 has an odd multiplicity, thus f changes the sign in the vicinity of 4 from positive to negative. 2 has an even multiplicity because of the square, thus f does not change the sign in the vicinity of 2 and continues to be negative. 1 also has an even multiplicity, thus f does not change the sign in the vicinity of 1, and continues to be negative. Negative 3 has an odd multiplicity, thus f changes the sign in the vicinity of negative 3. Change from negative to positive. The graph of f is above the x-axis on open interval negative infinity negative 3 united with open interval 4 infinity. The graph of f is below the x-axis on open interval negative 3 1 united with open interval 1 2 united with open interval 2 4. Place the intercepts on the axis. Draw the vertical asymptotes. Draw the horizontal asymptotes. The graph of f towards negative infinity could be above the horizontal asymptote or below. The graph must approach the vertical asymptote without crossing the x-axis because there is no x-intercept before negative 3. Thus, the graph towards negative infinity is above the horizontal asymptote and increases towards the vertical asymptote x equals negative 3. The graph is below the x-axis on open negative 3 1 united with open 1 2, intersects the y-axis at 0 negative 1/3 and the x-axis at point of coordinates 1 0. Thus, the graph continues at the bottom on the right side of the vertical asymptote x equals negative 3. The graph increases towards the 2 points and then drops towards the vertical asymptote x equals 2 because the function is negative on open interval 2 4. So it goes up, hits the intercepts, and then back down. The graph is below the x-axis on open interval 2 4, thus the graph continues at the bottom on the right side of the vertical asymptote. Increases towards the x-intercept, crosses the x-axis, and increases towards the horizontal asymptote y equals 1. This is thus the graph of f. The range of the function is open interval negative infinity 1 united with open interval 1 infinity. The end.